Hi, I am Avinash, and today in this video I will be talking about the brushless alternators and three-phase synchronous motor. So let us look into the alternator. Uh, Alternator, it is an electrical machine which converts mechanical energy into electrical energy. This is the diagram I have drawn. This is the simple diagram of an alternator where the conductor is placed between the two magnets, and it is connected with the slip rings, and these are the brushes. These days generator does not have slip rings or brushes, and they are called brushless generators. So we will be basically talking about the brushless generator in this video. So let us look into the brushless generator, also known as or alternator. So I have drawn this diagram. Here, this is the exciter coil. This is the exciter coil. This is the exciter rotor. This is the exciter rotor. This is rotating rectifier. This is alternator motor. This one. This is the alternator motor, and this is the output switch to the board. So in this whole part is a moving part, and this part is a stationary part. So here is the AVR. Okay. The brushless generator. This brushless generator having exciter coil, which is having a small residual magnetism. This exciter coil having a small residual magnetism. This magnetism produces the magnetic field. Which is cut by the exciter rotor. Hence, the EMF is produced inside it. And this EMF is alternating in nature. It is converted into DC. It is converted into DC by the rotating rectifier. This DC goes to the alternator rotor. Which will further produce magnetic line, and this is cut by the stator, which will further produce magnetic line, and which is cut by the stator. Here the stator. So hence the EMF is produced. Hence again the EMF is produced here. You can see in the stator. It goes to the various consumers and goes to the AVR, also to the AVR. And AVR, you can see AVR control the voltage to the exciter coil, and it also maintains the DC supply to the exciter coil. So the next one is the synchronous motor. A motor having a speed directly proportional to the frequency of the alternating current power that operates it and independent of the load. So this is the construction of synchronous motor. It consists of stator and rotor. The stator core is constructed with the silicon lamination and insulated by a surface coating. The stator has axial slots inside, in which three-phase stator winding is placed. The stator is wound with a three-phase winding for a specific number of poles equal to the rotor poles. So I will be better explaining with the help of a diagram. Okay, this is the simple diagram of a three-phase synchronous motor. As you can see, this is the stator, and here in this part, this rotor is placed inside, and these are the conductors placed where the three-phase windings are done, and this is the three-phase winding. Okay, this is the three-phase synchronous motor. And it can be constructed with wider air gap than induction motor, which makes this motor mechanically more stable. So I hope you enjoyed the video. Thank you.